Hi friends, welcome to this session of logical reasoning where we will look at problems that have some mathematical base in them. So the first of that is a very commonly seen puzzle. Here an insect is climbing up a 10-meter high pole. It climbs up 3 meters in the first minute but slips down 2 meters in the second minute. Again climbs up 3 meters in the third minute, slips down 2 in the fourth, and so on. We need to find out how much time would it take to reach the top of the pole. This must definitely be a fairly heavy insect, I guess, or the pole is fairly greasy. So here you have a pole, and the first minute it went up 3 meters, in the next minute it dropped 2 meters. So in effect, in 2 minutes it has ended up making only 1 meter. You may be thinking that okay, it does 1 meter in 2 minutes, and hence in 20 minutes it must be able to reach the top of the pole. If you're thinking on that lines, be a little careful. I think you got it wrong. That seems to be the most obvious answer, but that's not the actual answer. How do you then actually approach this question? Let me look at when it has reached 7 meters. Why 7 meters? Because the next jump of the insect is going to be a 3-meter jump. There it would reach the top of the pole. So let me see how much time would it take to cover 7 meters. 7 meters it would do in 7 into 2 or 14 minutes. So in the end of the 14th minute, the insect was at the 7-meter mark. In the 15th minute, it's the turn of the insect now to jump, and it jumps 3 meters, and hence you will find that at the end of the 15th minute the insect would be right on top of the pole. So you got to be a little careful about marking it as 20 minutes. That looks like the most obvious answer in this case. Let's look at the next question. A bus for Delhi leaves every 30 minutes from a bus stand. An inquiry clerk told a passenger that the bus had already left 10 minutes back. So the bus has actually left 10 minutes back. And the next bus is going to be at 9:35. So obviously, since every 30 minutes there is a bus that is leaving, this bus must have left at 9:05. Hence the time should have been 9:15 at the time when the person inquired at the counter. So it's fairly simple. This is a question on islet. This question is very similar to the question on the insect, right? And this is a question that's come in CLAT. Arun can climb a coconut tree by 1.5 feet in each lift. So Arun must be from Kerala. So he is climbing a coconut tree. However, he slips 0.5 every time he makes a lift. So he goes up 1.5 and he slips 0.5. So end of the minute he is done 1 meter. So effectively every lift that he does is actually doing 1 meter. Now let me look at how much time it would take to cover 17 feet. So you would have to do 17 jumps to reach 17 feet. Thereafter he still has to do a 1.5 meter or 1.5 feet jump, which would be the case of his 18th jump. Hence the total number of lifts that he needs to reach the top of the coconut tree is 18. Again, here there is a likelihood of you marking something other than 18, or probably you would have marked 19 as the answer, because 18.5 you would not know which way to go, either to 18 or to 19. So it's likely that you would have marked 19 as the answer. Let me look at the next question. A man went to a Reserve Bank of India with 2000 rupees. He asked the cashier to give him only 10 rupee and 20 rupee notes in return. In fact, the Reserve Bank guy would have sent him back and said, please go and check it in your own bank. Reserve Bank doesn't deal in all this. The man got 150 notes in all. How many notes of 10 rupees did he receive? So this is a question from CLAT. So 2000 rupees was what he should get, and he should get 150 notes, and some of them are got to be 10 rupee notes and some of them have got to be 20 rupee note. So the question is, how many 10 rupee notes would he have received? So let me start by assuming I am using the logic of incremental increase. So let me start off by saying that all the 150 notes were 10 rupees. What would have been the value? 1500 rupees. So if all the 150 notes were 10 rupee notes, the value would be equal to 1500 rupees. I need to increase this by 500 to make it 2000. For every 10 rupee note that I have, if I exchange it with the 20 rupee note, the net value that's going to increase is going to be 10 rupees. I need to increase the value by 500. So what is it that I need to do? I need to exchange 50 of these 10 rupee notes with 20 rupee notes. So effectively, finally, I'm going to have 100 10 rupee notes and 50 20 rupee notes. So you can actually check, multiply it and check. You will find that the answer is adding up to 2000. Hence, in this question, the answer is A. The present ages of the father is equal to the age of his 3 children taken together. After 9 years, age of the father will be equal to the sum of the ages of 2 eldest children. 3 years after that, it would be equal to the sum of the ages of the eldest child and the youngest child. Again, after 3 years, it would be equal to the sum of the ages of the 2 youngest children. What are the present ages of the youngest child and eldest child? This looks more like algebra question. So there's a little bit of less of reasoning, more of algebra in this question. So here we have the father's age is equal to the age of the youngest plus the middle plus the eldest child. After 9 years, father is going to become f plus 9 years, and his age will be now equal to the sum of the ages of the 2 eldest children, m plus 9 plus e plus 9, because both of them are also grown 9 years older. So if you subtract equation 2 from equation 1, you will find the value of y is equal to 9. So you subtract the left hand sides, you get 9, right hand sides you end up getting y minus 18. So you will get the value of y as 9. Now let me look at the third condition. The third condition says 3 years after that, it would be equal to the sum of the ages of the eldest child and the youngest child. 3 years later, father's age is going to be 12. It would be equal to the eldest and the youngest. So you will find that eldest is going to be e plus 12 and youngest is going to be y plus 12. Now if you use equation 1 and equation 3, you will find that the age of the middle child will be equal to 12. You subtract the left hand sides, you subtract the right hand sides, you will find that m will be equal to 12. Similarly, the next condition says again after 3 years it will be equal to the sum of the ages of the 2 youngest children. So f plus 15 will be equal to the 2 youngest will be m plus 15 plus y plus 15. Solving this and subtracting equation 4 from equation 1, you will find that you will get the eldest child is 15 years old. So you will find in the given question what are the present ages in years of the youngest child and the eldest child. Our answer would be equal to B. So this is actually an algebra question which has come in one of the exams, not the exam before CLAT. I think it has come in the NALSAR exam. So we will close it at this and then see you again in the numerical reasoning session 2.